Okay, similar to what we were learning about the direct calculations when we were learning about interpolation, how the Newton method starts is exactly the same. Similar to what we were doing for the linear interpolation that we were doing, we were considering to have 2 points, 2 data points. Do you remember when we were talking about linear, quadratic, cubic, and so on? So for linear, we were dealing with 2 data points. And the same here, for linear Newton's method, for linear calculations for Newton's methods, we are talking about 2 data points. And the result is because we are having only 2 data points, the solution is going to be just a line, because we only have access to 2 data points for our data that we are considering for our calculation. Similar to what we had for the direct method, we just defined what is the slope of this line and so on. But the main thing for Newton methods are these B0, B1, B2 up to Bn. It depends on if we are doing the linear, quadratic, cubic, and so on. So the very first, I write my result as f of something. If this subscript is 1, I'm talking about linear. If it's linear, is a number of points minus 1. So when I have 2 points minus 1, there's my pen. When I am talking about f1, I mean I am dealing with a linear calculation. Because that's basically n is number of points that I have. N minus 1 is what I have here. And f1 means I have 2 data points only. f2 means I am considering 3 data points. So my approximation would be quadratic, right? If I have f3, I have 4 data points. So my approximation would be cubic, and so on and so forth. So when I talk about f1 of x, it consists of 2 data points. The first one is b1, 2 data points. So I rewrite it as this. So then I want to talk about b0. b0 is always equal to f of x0. Because for each point that you have an x and you have a y. So when you want to, basically you have x0 and f of x0. You agree for each point. F of x and f of x. x1, f of x1. x2, f of x2, right? So I call this f of x1 as my b0. Always I call that as my b0. For b1 though, I don't call it equals to f of x1. b1 is this. b1 is f of x1 minus f of x0 divided by x1 minus x0. So, what does that tell you when you look at this formula of b1? It represents, it's basically the first derivative of your function. The first derivative of your function is the slope of the line that attach these 2 points to each other. Do you agree, everybody? It's the difference between f of x's, which is the second one, that y1 minus y0 divided by x1 minus x0. Everybody agree? This is the slope of the line that attaches 2 points to each other, right? So, this is actually very, very interesting approximation. At the beginning, it's not as handy, but as we go through, you see that how simple and fun is that. So, I call the second want my b1 to be simply equal to f of x1 minus f of x0 divided by x1 minus x0. So up to here, I can write the equation for my line, which is the function when I'm finding my linear approximation solution, to be equal to b0 plus b1 x minus x0. That's the solution that I get by having that. As long as I know what is my b0 and b1, I'm able to put them back and then I solve my problem. That's so easy. But now we want to know, what if I want to go one step further? Oh, here is an example. Let's look at the example using the linear Newton method to solve our example. The same example as we had. And the simple thing is that for all equations, we are using the same problem over and over. So you are just learning about it better as it goes. So the same problem that we were solving last time, I want to know what is the velocity of my rocket at t equals to 16 again. But I want to use my linear interpolation using Newton method this time. I'm not doing it directly, okay? So, but all the steps are exactly the same as we had before. So what was I using previously when I wanted to do that? I have to have two x's and two f of x's, or t or f of t. So how do I use them? Which ones is better for me to use? For this, because this is a table that I have, which points should I choose? 15 and 20. So my points, my t's are going to be 15 and 20. Why? Because these points are closest to t equals to 16, right? Now that I have my t's, I have my f of t's, and I can simply find my solution. So I say, okay, I call the first point t0, the second point t1. So my t0 is what? My t0 is 15. My v of t0 is equal to 362.78. My t1 is equal to 20. My v of t1 is equal to 517.35. Now that I have my data points, tell me, what is my b1, b0? My b0 is f of x0, which here is this, v of t0, right? 362.78. Now I want to know what is my b1, because my goal is to write my v of t equals to b0 plus b1 f of v of t minus t0. This was the formula that I had at the other slide for f of x, right? So what is my b1? My b1 is v of t. I don't put values, I just write it as that. v of t1 minus v of t0 divided by t1 minus t0. Everybody agree? If I put these values that I have, these are v of t1, v of t0, all of them are some values. These are not functions. These are these values that are introduced here.